Bash scripting is dead. Bash is evil. Bash is inconsistent. Bash is a terrible language. Bash is hard to maintain. You should not touch Bash. I'm sure you've heard all of these arguments before. Well, there's definitely some truth to all of this. However, there's also no denying that Bash is the glue between all the command line utilities. There's just nothing that compares to its interoperability capabilities. A pattern I really like at GitHub is the scripts to rule them all. Not everyone is a fan of it, but I think it works. It's basically a set of scripts that are standard across all the repos of services at GitHub. Whichever service you touch, you can always know for sure that script/bootstrap will install your dependencies and prep your dev environment. Script build will build the service. Script test will run the tests. You get the point. Now, everybody who likes makes files is sort of cringing right now, but they're not mutually exclusive. You can use them both at the same time. Now, these scripts obviously call on other dependencies and tools, but they're the starting point for pretty much everything. And guess what? The vast majority of these scripts are written in none other than Bash. So the argument of whether this works at scale is kind of mute in my opinion. Now let's get a bit more practical and discuss my 10 tips on how to make your Bash scripts better and more maintainable. This is a beginner-friendly video, so let's dive in. Now, before we start with our first tip, let's create a simple Bash script, which is we start with the shebang. And then we are going to declare that we are using Bash in this case. Now, the behavior of our script will change with this tip because we obviously want our script to fail fast and quickly and as verbose as possible. And we do that by doing set-euo pipe fail. And let's break down what each one of those does. -e or -o, we can also set it like that in the longer form. Basically causes the shell to exit immediately if any command in the script exits with a non-zero status. This basically helps us catch errors early, and it will prevent the script from continuing to run in a completely unexpected state and behavior. We don't want our commands to fail silently, and we want to catch them when they are failing. The next one is -u. We can also set it by saying -o, no unset. And what this does is it causes the shell to also exit immediately if it encounters an unset variable. So we have to declare all the variables that we use in the script before we actually use them. It doesn't matter whether you do it at the top or in the middle. In my opinion, at the top is definitely cleaner and much better, but you have to define them or declare them before you start using them. And the last one is -o pipe fail. And this option affects pipelines. Pipelines are when you do something like echo, hello, and then you do maybe a grep, let's say on H, and then you do a cut whatever, D something, and then 1, let's say. Normally, the exit status of a pipeline is basically the exit status of the very last command, which is cut in this case. However, when you set the -o to pipe fail, and it basically enables this failure, the pipeline's exit status becomes that of the rightmost command to exit with a non-zero status. So let's say in this case, grep exits with a non-zero code. The script will fail at that point, and it will give us the status code of grep as opposed to whether cut has succeeded or not. Because even if grep fails, sometimes, cut will act on the output of grep to standard output. Even because sometimes commands fail, they push stuff to standard error, and they still push stuff to standard output. So that's what we want. That's the behavior we actually want, because we also want to detect failures in any part of the pipeline. Tip number 2 is understanding exit codes. So exit codes are numerical values, they're integers, that a process returns to its parent process when it has finished executing. So the shell is obviously a process, and it can run its, scripts, or it can run commands, or, GNU tools, whatever it is. So whenever one of these commands finishes, it returns an exit code to its parent process, basically the shell in this case. Now, these codes are a form of inter-process communication, allowing the calling script, whatever that is, or the program, or even the user, to determine the outcome of the executed command, script, or program. Now, be careful because there are some reserved exit codes. These codes are reserved because they are intended to convey common types of program terminations or errors in a very standardized manner. When in your bash scripts you override these codes or you misuse reserved exit codes, you are basically miscommunicating and violating that standard. And I see that sometimes in a lot of scripts where they do an exit, but they don't provide the correct exit code. And let's give you an example of how exit code behaves. So let's say echo hi. And in this case, echo has succeeded in printing hi. How can we check the exit code of this command? We can say echo $, and then question mark. This will give us the number 0. 0 means that the previous command has exited successfully. And then number 1 is a general error. This is just a broad catch-all error code, for general failures. So if you don't really know why your script has failed or you want to throw a general error, you can, in your bash script, say exit 1, for example, to designate an error. Never exit with an error and use the exit code 0. I see this very, very often in a lot of applications, and they are fully misusing these reserved exit codes. Now, number 2, or exit 2, is basically reserved for the misuse of shell built-ins. So this code is often indicates that a shell built-in received incorrect arguments or is otherwise misused. And examples of built-ins are like commands that are not external to the shell. So cd, right? When we type in cd and then provide the path, this is not a path. Obviously, this is wrong. So when we provide a path, this is a built-in command. When we do echo, when we do exit, these are also built-in commands. Now, certain exit codes are reserved for specific purposes also by bash and sometimes also by convention between, among the Unix and Linux users. So when you exit with number 126, this number means that the command cannot execute. The file that is being called is recognized, but it cannot be executed as a program. This could be due to permission issues. So let's say we have a simple bash script. Let's do this one more time. Let's start with the shebang bin bash, and in this case we are not doing anything special. We are simply doing echo hi. Yeah, whatever. We're gonna save this file and then we are going to try to run it. And in this case, it says permission denied. And if I check the exit code, it's gonna be 126. Now, if we do chmod a+x unscript.sh, and then if we try to run it again, it's gonna output hi with a question mark. And then if we check the exit code, in this case, it's going to be 0 because it exited successfully. Then we have number 127, which is command not found. So if you are trying to run a command that is just not available, let's say this one, obviously, we do echo again, $, we're going to get 127. The next one is number 128, which means that you've provided an invalid exit argument. So if you say exit -1, for example, your script or whatever you're using is going to fail with that particular exit code. Then we have 128 plus a number. This is a fatal error signal. And if a program is terminated by a signal like a sigkill, for example, bash will use the exit code 128 plus the signal number. So sigkill is a signal number 9. So let's say, let's give you a concrete example. Let's say sleep 100, and then we are going to open a new window here, or a tab. Sorry, pane. so much terminology. And let's do a grep on the sleep so that we can get the PID. And then we do a kill-9, and then we specify 73213. When we do that, the sleep command is killed in this case. And if we do echo and then a $, we're going to get a 127. What is that number 127? It's a 137. It's 128 plus 9. That's what it actually means. So when a program exits with a status code, you can remove 128 and understand which signal terminated or with which signal that script has exited. Then we have 130. This is when we basically kill a script with the control C. Again, let's go back to the 100, and then we do command or control C. and then we do echo $? We're going to get 130. Why? Because it's going to be 128 plus 2. Now, tip number 3 is parsing named arguments. Why? Because we want our scripts to be able to do stuff. We want to provide it with some input, and we want to be able to execute on that input that we provided. So how do we do that? We start with a while loop, as you can see over here. And then in this, conditional check, we are looking at the number of arguments that is provided. And as long as that number is greater than 0, we are going to keep on looping. Then we're going to use a sort of a switch statement over here, and we're going to look at the first argument that is supplied. And if that argument is equal to -a or --option A, and you can here change it to whatever you want, we're going to make a value, this is a variable, be equal to the second positional argument. So the value is going to be embedded into this variable over here. And then we're going to shift because we want to move off from this argument so that we can parse the second one. And it's going to take it off of our list of arguments, basically. And then we enter the loop one more time. And then this time, let's say we have -b, which is --option B. And then we do the same thing. And then here we break. Now, if we have passed an argument that is not in this switch statement, we're gonna catch it with this, and we're gonna exit with a code number, with error code number 1. This signals that we have provided a parameter that we really, it's unknown and we don't know what to do with it. Now, the next tip is asking the user for their input and then verifying that input. And we can do that very easily by using or leveraging the command read. Read, we provide it with the option -r, which prevents backslashes from being interpreted as escape characters. And then -p is basically our prompt. And then we give the user the hint of the types of responses we expect from them. Yes or no in this case. We can obviously make it case sensitive or insensitive, whatever you prefer. This could be an option. And then we are recording the response that user provides in this variable over here. Now, in order to check the response, we jump to this conditional over here, and a response variable, we're going to compare that to a regular expression. If you can notice here, we have the equal tilde sign, which means that we are comparing not a string to a regular expression. And this is our regular expression over here. And what is actually happening in this case? We start with the hat sign. I forgot what it's actually called. And then we are comparing against, the combination of small y or capital Y, E or capital E, S or capital S, or the value Y. So either if the user provides the value yes, written as a string, or just simply Y, we are going to match with this. And here we are checking, whether this regular expression or asserts that the preceding pattern basically must occur one or more times. And we are also specifying that we want it also to be the end of the line and that the user has not supplied anything else. So if this condition is met, this is basically our, true statement or true state. This is where we want to basically execute on whatever the user has supplied. Otherwise, we have the else statement. Now, what is the problematic part about this? And it's going to take us to tip number 5, which is how do we know that the user is actually running in a terminal? And this is where we need to introduce terminal tests. And how do we do that? By introducing yet another condition, which in this case is if test-t0 then, oops, sorry, not here. This is the wrong positioning. This is where it should go. If the test-t0, then, and then we need to grab all of these and add some indentation and then finish this with a phi. We also need to probably add an else over here because we want to handle the alternative. All right, so what are we looking at over here? If test-t0, what does it do? So the test evaluates to, test-t0 evaluates to true if the file descriptor 0, which is synonymous to standard input, is open and it refers to a terminal. This is how we test it. This is often used to determine if a script is being run interactively or if its input is being redirected or piped from another command file. So this is how you know that you are running in a terminal and that someone is not, piping input to this bash script over here. And then we have the minus or -t, which is the option used with test to check if the file descriptor is associated with the terminal, obviously. Now, if we are running in a terminal, we want to prompt the user. Otherwise, we don't want to do that. And this is how we can achieve this outcome. Tip number 6 is checking if a command exists before we actually use it. Now for this one, we have 3 options. We can use either command -v, we can use the second option, which is type, or the third option is to use which. And each one of those has pros and cons. So let's actually go through all of them. Command -v is basically the most portable. This is the POSIX compliant way to check for the existence of a command. It's highly portable across different Unix-like systems. Now, in terms of functionality, it can check for pretty much all the types of commands, including aliases, functions, or built-ins, or even external commands. Now, the second one is type. In terms of portability, type is also a shell built-in most bash shells, making it widely available and portable. Type not only checks for the existence of a command, but also provides information about what kind of command it is, whether it's an alias, function, built-in, or a file. In terms of use cases, it's best used with interactive scripts or when you need detailed information about a particular command. It's also good for portability. And then the last one is which is the least portable because it's an external command. It's not a shell built in, and its behavior and output can vary greatly across operating systems or across distributions. So use it very sparingly. I'm not sure what's the advantage of it, but maybe one of the advantages is that it can do searches in the directories listed in the path environment variable. It does not detect shell built-in or functions. So even the functionality is extremely limited, and it's still an option if you so desire. Now, how do we effectively use either of these options? Let's start with command. It's very simple. We put it in an if conditional, and then we pass -v, and then the command we want to check its existence or not. And then we pass we pipe the standard output and standard error both to dev null, because we're going to get rid of them. We're not going to use them. We just care how this command exits, with whether exit code 1 or 0. And if it exits with 0, then the command exists, and then we can do stuff in the condition. Otherwise, we need to do other stuff. Now, how do we do the second one, which is type? Pretty much very similar to how we run the command. And in this case, we are also passing the standard output and standard error both to dev null. And the last option of the bunch is basically the which. Now, in this case, you will notice that we are not passing the standard error to dev null. Why? Because which is not as portable and it might not exist. And if it doesn't exist, that error is going to be pushed out to standard error as a file descriptor. And we want to be able to read that and react on it. So that's an error you definitely don't want to suppress. Tip number 7 is using a trap to point to failures and specific errors on specific line numbers of our script. Now, we have set the -euo pipe fail, but that's not necessarily enough because it's going to fail. The script is going to fail whenever we have a failure, but it's not going to tell us where exactly. And sometimes the error messages are cryptic, and it forces us to go back to the script and try to read it. And for very long scripts, this is very, very painful. What we actually want to do is to use trap. Trap is basically a command that will catch signals, and it will execute this particular echo whenever that signal is caught. And in this case, we are echoing a simple string which says script failed at line, and then we are using the variable line number. Now, line number is in bash, it holds the current line of the script that's being executed, which is very useful for debugging. And then at the very end, we have the term here, error. And error is basically the signal that trap is catching. The error signal is not a system signal like sigint or sigterm, but it's specific for the shell, and it is triggered whenever a command returns a non-zero exit code, which in this case, the combination of all of these is very, very, very useful to our particular use case. Now, you can obviously rewrite your trap message to capture other signals like sigint, sigterm, sigkill. It's really up to you what you do with it from here. Tip number 8 is to use functions to compose your scripts. Now, everybody who learns programming learns that functions are very useful to avoid rewriting code, to structure, a certain piece of code. However, when it comes to Bash, I see a lot of people just, stacking different types of commands without really structuring their scripts in terms of functions. And the reason for that is I think a lot of people don't really understand how functions work in Bash. So let's take a quick example over here. We have the function defined as check file. It doesn't really require any previous statement to define a function. You can just type in its name and then the couple of parentheses and open the curly brackets. And what this will do is it will have a first condition where it is gonna check whether that file exists or not, and the file is gonna be specified by the first argument passed to this function. We're not doing any type checks. We're not doing any checks on, the content of this argument. So this could go, really wrong, but this is just to illustrate the point. So if the file exists, we're just going to echo, again, number 1, which is the first argument, and we're going to say that this file exists, and then we're going to return 0. Otherwise, we are going to echo that the file does not exist, and then we're going to return 1 because the function has actually failed. Now, how do we call this function? You can just simply call it like this in your file, and then just pass the file as a string to it, and it will run just fine. And if you want to check the exit code or whatever this function has returned, you can just simply, echo return and then use the $? over here to get the exit code or the return code from this particular function. Now, before we move on to tip number 9, I just want to clarify also, how do you return values from functions in Bash? So functions in Bash don't return values in the same way functions in other programming languages do. Instead, functions, they return exit status codes as we just demonstrated in the previous step. You can mimic the behavior of returning a value by using echo or printf to output the value and then capture this output when calling the function. This is commonly done with command substitution. So let me give you a small example of how you can achieve this. I already have the example right here, so let's put it over here. What's going on is we have a function called getPersonalInfo, and then we are passing 2 arguments to it. First one is the name and the age, and then we're just simply echoing the name and then comma age. Now, how do we capture what has been returned by getPersonalInfo? First of all, we wrap the function call with these parentheses and $, and that what this will do is it will execute getPersonalInfo, and then it's gonna store the standard output or the output that went to standard output in info, the variable. Then we are going to read the info over here, and we're gonna use the comma as a separator for the different values. And then what's gonna happen here is if we echo the variable name and age, we are going to get their values instead of, nothing in this case. And the whole trick is done because of the use of IFS in this particular case and the comma. Tip number 9, add usage documentation. Now, a lot of people fail to do this in their scripts, and it leaves others, scrambling for information. How can I get how you can use this particular script? What are the parameters that you expect? What do you return whenever you execute? So it's very useful to do it this way. What I like to do at the beginning of every script that I have is to add something like this, where I describe what the script does in detail, and then I add the usage, where this is the script's name, and then all of the parameters, different options. And then if I have some named parameters, what are they? And then help, how they can people fetch this basically help message and display it. And this is a pretty neat way to document what your script does, what is the expected output from it, and what are the arguments, positional or named parameters that the script expects. Tip number 10. This is cool and all, this, documentation, but I actually want people to be able to see it whenever they pass --help or -h. Now, how do we modify our parsing of the named parameters over here so that we can return it? First of all, we need to remove this break over here. And then what we want to do is to actually pass -h or --help. Let's add a space over here. And then what we want to do is to use the following. I'm going to copy it because it's a bit faster. Let us paste it over here and make sure the indentation is correct. And then we're going to do exit 0 over here. So what this does, this is a pretty neat trick. It's going to do a grep, but it's going to do grep where? First of all, it's going to grab the file's content. It's going to do a grep on this actual file because the $0 is the file's path. Then it's going to read this file and going to pass it to grep. And then it's going to look up for all of the lines that start with hash and then /. And then what it's going to do is going to cut the first 4, characters of that particular line. And it's going to output these values. Now, what this does is, let's also make sure that we exit cleanly. So what this will do is it's going to go all the way up here, and then it's going to grab all of these lines. It's going to strip the $/, and it's just going to output this string back to our users. And this is a pretty neat way, to just write, not necessarily have to write this documentation in a function or anywhere else. You can maintain it at the beginning of the script and at the same time output it as a response to the -h or help parameter. Now, I promised you 10 tips, but because I'm a great guy, I'm going to give you one more, which is tip number 11, how to write a nice and clean or cool log function. Logs, I pretty much, use it quite often to log outputs. And I think you should too. So instead of using echo and, very boring echo, use this particular log function. And what this one will do is, as we talked about, how functions are defined, we're going to read the first argument that is passed to log, and then we're going to check what it is. So you can pass to it either error, capitalized, or, small case, info, or warn. And in any of these particular scenarios, it's going to add this nice small, exclamation mark or the plus sign, depending on the type of what we are trying to log. And it's going to color it. And then it's going to read whatever we pass afterwards, whether it's a single string or multiple arguments of strings. And then it's going to output them to us or to our terminal because we are using printf. Now, why are we using the $B as opposed to using $S, for example? Because $B will retain and it will not escape the \t or \n that we provide, which means that we can log multi-line messages, we can log stuff with tabs, we can log stuff with colors or whatever, and it's not going to be escaped. It's going to be printed as is. And basically, I just showed you the fundamental structure of every, bash script that I tend to write myself. These are 11 tips of how you can make your scripts a little bit more readable, more composable, easier to troubleshoot, easier to debug, and it's going to make bash a little bit less of a pain to work with. And it's going to make it closer to what you're currently used to with other programming languages. Now, as a conclusion, I could already hear a lot of people complaining about bash, and they're still going to complain about it. Some people understand bash and they complain about it because it's a bit painful to work with. And some people don't know bash at all and still complain about it because it's difficult and cryptic for them. Now, why would you use bash scripts in 2024? There are obviously better alternatives out there. And that's, very true. If you're starting fresh and you have options, don't use it. Why would you? Any modern scripting language will do the job just fine and probably even better. Many of them already come pre-packaged in different operating systems. So the portability argument for bash is slightly less strong. But we are engineers, and if there's a tool that is currently being used in our landscape, we have to learn how it works. Honestly, when it comes to doing things in my terminal, I often default to using bash because it's just so neatly integrated. Now, all the other programming languages come with vibrant ecosystems of packages, rich internal APIs and whatnot. But when you want to interface software written in different languages, things can get complicated real quick. The composability aspect of the command line tools is just amazing. Thank you for the Unix philosophy, and the ability to pipe simple outputs from one command or one script to another, and having bash deal with the plumbing of everything together makes this whole ecosystem so powerful, extremely pragmatic, and highly effective. And that's why I still think in 2024, it's highly useful to learn how to use bash and to benefit from the power of, it being the glue of everything together. I hope this video was useful for you. Like, comment, please share it with anyone who you think would benefit from this video. Watch my other videos. This will help me tremendously keep going with this channel, and it will help me tremendously fund the channel and fund future videos just like this. Stay awesome, and I will catch you next time.